potential due to a single point charge. Earlier we are discussing about the electric field due to a single point charge. The most important thing कि जो अपन ने पीछे इलेक्ट्रिक फील्ड पढ़ा है उस इलेक्ट्रिक फील्ड की डेफिनेशंस को द फॉर्मुलेशंस ऑफ द इलेक्ट्रिक फील्ड आर डायरेक्टली टू बी यूटिलाइज्ड इनटू इट. यहाँ पर इस पर्टिकुलर फॉर्मुलेशन में डायरेक्टली यूज आएंगे. दैट्स वाई वी आर कंसिडरिंग द फॉर्मुलेशंस. प्लस क्यू चार्ज इज टू बी प्लेस्ड हियर. यहाँ पर एक पॉजिटिव प्लस क्यू चार्ज रखा हुआ है एंड ए टेस्ट चार्ज क्यू नोट इज टू बी प्लेस्ड एट द डिस्टेंस एक्स फ्रॉम दिस प्लस क्यू चार्ज. इस प्लस क्यू चार्ज से एक्स डिस्टेंस पे अपन ने क्या रखा है कि पॉजिटिव चार्ज टेस्ट चार्ज क्यू नोट रखा है. इफ वी आर हैविंग द फॉर्मुलेशंस जो अपन ने अर्लियर फॉर्मुलेशंस पढ़ा है, दिस क्यू नोट इस प्लस क्यू की वजह से इस क्यू नोट पर एक फोर्स लगेगा. इट इज टू बी इन टर्म्स ऑफ द क्यू नोट इंटू ई. देन ये जो क्यू नोट है ये एक अपोजिट फोर्स लगाएगा टू मूविंग टुवार्ड्स दैट पर्टिकुलर इलेक्ट्रिक फील्ड. इफ इट इज टू बी मूविंग इनटू दिस फॉर्मुलेशंस, if we are considering the displacement in terms of the dx, यदि ये dx move किया, then the forces here, the forces are to be in terms of, it is not a constant force, it means it is a variable force. जैसे ये dx move करेगा, it means when it is to be moving towards the electric field or the center of that particular positively charged placed, वैसे वैसे फोर्स की वैल्यू इंक्रीज होती जाएगी. इट मीन्स द अपोजिंग फोर्स इज ऑल्सो टू बी इंक्रीज. दैट्स वाई अपन ने यहाँ पर एक छोटा सा वेरिएबल डिस्प्लेसमेंट कंसिडर किया इन टर्म्स ऑफ द dx. देन द फोर्स इज टू बी इन टर्म्स ऑफ द F इक्वल टू क्यू नॉट ई. नेक्स्ट द वर्क डन. अब अपन वर्क डन की बात कर रहे हैं कि वर्क डन कैसे कैलकुलेट होगा. देन दिस वर्क डन इज टू बी डिफाइंड इन टर्म्स ऑफ द F इंटू dx. dx is to be the displacement of the test charge. Value of the F is to be in terms of the q naught into E equal to dx. Then dw equal to q naught E dx cos 180. 180 because both of them are to be moving into the opposite directions. Their forces are to be in opposite direction. That's why we are considering the angle here 180 degree. Then cos 180 degree is to be equal to minus 1. That's why the dw is to be equal to minus q naught into E dx. Then as per the formulations we are considering the for value of E equal to kq upon r square. Here in place of r we are using the x. That's why we are considering E equal to kq upon r square. And here the x square and the value of the k is to be 1 upon 4 pi epsilon naught. That's why dw is to be minus q naught upon 4 pi epsilon naught x square dx. Here if we are just to be having the formulations, then E की formulation आपको दे रखी है. Then to calculate the net work done, if you are considering the formulations, if you are considering that particular test charge at infinite, then we are calculating the work done from infinite to point B. Here we are integrating from infinite to B and our limits are infinite to R. K q naught upon x square. Here the as per the formulations 1 upon x square is to be integrated in terms of the minus 1 upon x and we are getting out the w infinite b upon q naught equal to q upon 4 pi epsilon naught r. And our final concluded result v equal to q upon 4 pi epsilon naught r, or we are just to be considering v equal to kq upon r. It is to be the electric potential due to a point charge. Next we will consider electric potential due to a group of point charges. Here we are having the multiple charges. This case is already to be discussed into the first chapter as well as the second chapter. Here we are just to be considering the superposition principles. It means we are having the multiple charges and we are just to be considering a test charge, and this test charge is to be moving into the electric field. And if we are having the multiple charges, then there are the multiple electric fields are to be exist. It means each and every charge is to be applied a force upon that particular test charge. That's why we are just to be concluded the net electric potential is to be defined in terms of the Vp equal to V1 plus V2 plus V3 plus V4 plus Vn. Here the electric potential or the voltage are to be scalar quantity. That's why we are not to be considering it is a vector summation. It is a normal summation of a that's. Then V is to be equal to, as per the formulation it is to be kq upon r, but here the values of the q are to be different and values of the r to be different. That's why we are considering it is to be the k summation q upon r. Here the qi and ri. I is to be started from 1 to n. Then as per the formulation, it is to be defined in terms of the position vector. If we are considering the as per the position vector, then the R is to be defined in terms of the differences of the position vector. Here the electric potential at a point due to a charge is not affected by the presence of other charges. इसका मतलब ये presence of other charges से कहीं भी आपके पास अफेक्ट नहीं हो रहा है. इसका मतलब जो आपके पास एक चार्ज है उसकी वजह से जितना इलेक्ट्रिक पोटेंशियल होगा, इट मीन्स अपन को यदि Q4 पे इलेक्ट्रिक पोटेंशियल कैलकुलेट करना है तो अपन सिर्फ Q4 की इलेक्ट्रिक फील्ड में जैसे ही टेस्ट चार्ज आता है वो क्या इफेक्ट शो करता है वो कैलकुलेट करते हैं. दिस इफेक्ट इज टू बी कंसिडर्ड एज द इलेक्ट्रिक पोटेंशियल ड्यू टू Q4 charge. Here the electric potential is to be inversely proportional to R as per the, and in case of the Coulomb's force it is to be inversely proportional to R square. It means if you are just to be comparing the formulations, force में आपके पास क्या था, inversely proportional to R square, and same आपके पास किस में था, electric field में था inversely proportional to R square, but in electric potential it is to be inversely proportional to R. Next, the potential is a scalar quantity where the force is a vector quantity. Although the voltage is to be called as the potential at any point, but it is always to be calculated in terms of the potential difference between the point infinite and point R. Next, the electric potential due to electric dipole. This topic is to be important for exam point of view. In first chapter, we will also discuss about the electric field due to electric dipole. Here we are just to be considering the electric potential due to electric dipole. Here in first case we are just to be considering the electric potential due to electric dipole on a axial line. Here we are just to be considering, यदि अपन इस formulations को, इस diagrams को अच्छे से clear करें, we are having dipole in terms of the minus q and plus q charge, and they are to be separated by a distance in terms of the 2x or in terms of the 2l, and we are just to be considering a point P. It means test charge plus Q plus 1 coulomb is to be placed at the distance x from the center of the dipole. Now we are just to be considering the basic formulations. Then this distance is to be defined in terms of the entire distance is to be considered in terms of the x plus L, and this distance is to be considered in terms of the x minus L. Here we are having this formulations in terms of the x plus L and x minus L. Now the electric potential Vp due to plus Q charge, it is to be KQ upon R. In place of R we are just to be using plus Q के लिए formulation क्या था, x minus L. That's why we are using the x minus L here. Next, due to minus Q charge, it is to be K minus Q upon x plus L. Then the net electric potential, it is to be equated by to the summation of both the potentials. In case of the electric field, we are just to be considering the vector summations, but here the potential are to be a scalar quantity. That's why we are just to be considering the scalar additions. It is to be equated by Q upon KQ is to be taken out the common, and we are having the formulations 1 upon x minus 1 minus 1 upon x plus 1. After taking the LCM, it is to be a plus b, a minus b in terms of the a square minus a b square. It is to be x square minus a 1. Now we are just to be having the formulations here, the x plus 1 minus x plus 1. Then it is to be considered in terms of the x is to be cancelled out with the x, and we are getting out the 2 here. Then it is to be kq2 into L upon x square minus L square. It is to be in terms of the L and L, that's why it is to be 2L. Next, as per the definitions of the electric dipole moment, we are having the P electric dipole moment in terms of the magnitude of the charge into the separation between them, and here the separations are to be in terms of the 2L. That's why we are considering here the P, and Vp is to be written down in terms of the, it is the KQ upon, in place of the x square minus a L square. Now to be simplify, we are just to be considering an assumptions. Here the x is to be very greater than R. We are just to be considering x is very greater than L. It means x is to be eliminated, and we are considering the formulations, the electric potential due to electric dipole on axial line, it is to be equated by Kp upon L square. It is our final concluded answer. Next we will consider the electric potential ड्यू टू इलेक्ट्रिक डाइपोल ऑन इक्वेटोरियल लाइन. सेम फॉर्मुलेशंस जैसा अपन ने इलेक्ट्रिक फील्ड की टर्म्स में देखा था. हियर वी आर हैविंग द इलेक्ट्रिक डाइपोल माइनस क्यू प्लस क्यू. वी आर हैविंग a point q. It is to be at y distance from the center of the electric dipole. Then this perpendicular distance is to be considered in terms of the under root y square plus a l square. Here this distance is also to be considered in terms of the under root y square plus l square, and this is also to be same under root y square plus a l square. Now if we are considering the formulations, v due to plus q, it is to be kq upon under root x square y square plus l square, and it is also to be equal to k minus q upon under root y square plus a l square. Now as per the formulation, the net electric potential is to be equated by the summation of both the electric potentials, and the electric potential are to be defined in terms of the v plus q plus v minus q. Here we are having the formulations 1 upon under root y square plus l square minus 1 upon under root y square minus l square, y square plus l square. Both the quantities are to be same, that's why it is to be equated by 0. It means here the net displacement is to be defined in terms of the 0, and if this value is to be equal to 0, then the multiplication v is to be also equal to 0. It means the electric potential due to electric dipole at equatorial line, it is to be equal to 0. Next, the important topic. Sometimes 1 marks questions are directly to be asked from this topic in terms of the equipotential surface. Here we are just to be considering about the surfaces. It means we are having the multiple surfaces, and if we are considering each and every having the same potential, it means they are to be the equipotential surface. In another words, we can just to be expressed in terms of the a surface at every point of which the potential due to the charge distributions is same. It means if we are considering a particular surface and the electric potential of each and every point of that particular surface is to be equal, it means it is to be a equipotential surface. Here we are considering few examples. The plane equipotential surface is to be defined like this. If the electric field lines are to be passes through these particular areas, and the electric potential are to be in terms of the V1, V2 and V3. These are the equipotential surface. Here the V1 equal to V2 equal to V3. Now for the spherical equipotential surface, if we are having a plus q charge, then the electric field are to be considered in terms of the electric field lines in the circular formulations. That's why it is to be considered as the equipotential surface or the spherical equipotential surface. Next, the properties of the equipotential surface. Sometimes 1 marks questions are to be directly asked from the properties of the equipotential surface, like the properties of the electric field. Here first property is to be considered in terms of the no work done in moving. It is charge from one point to another point in the equipotential surface, because we are just to be considering the work done, and work done is to be always to be there, but due to the equipotential surface the net work done is to be equal to 0. That's why there is no work done to move a test charge from one point to another point into the equipotential surface. If we are considering both the points A and B are to be at equipotential surface, it means a work done is to be equal to 0. The next formulation, the electric field is always perpendicular to the element of the equipotential surface. It means the directions of the electric field is always to be perpendicular to the equipotential surface, because earlier we are just to be considering the work done is to be equal to 0. Then as per the definitions of the work done, W equal to E dot dl, and E dot dl is to be equated by 0 only when the theta is to be 90 degree and cos 90 is to be equal to 0. That's why both the surfaces are to be perpendicular to each other. Third property is to be the equipotential surface indicate a region of the strong or the weak electric field. It means with the help of the equipotential surface we can define whether our electric field is to be strong or the weak. the relation between the electric field and the electric potential is to be defined E equal to minus dV upon dr. Here the E is to be inversely proportional to dr or dr is to be inversely proportional to ER. It means if the equipotential surfaces, the separation between the surfaces are to be lesser, that's why due to the inversely proportional formulations dr to be less, E is to be greater. If dr is to be greater, then E is to be lesser. नेक्स्ट प्रॉपर्टी, टू इक्विपोटेंशियल सरफेस आर नेवर टू बी इंटरसेक्टिंग ईच अदर, कभी भी एक दूसरे को इंटरसेक्ट नहीं करते, सेम एज द इलेक्ट्रिक फील्ड लाइंस आर नेवर टू बी इंटरसेक्टिंग ईच अदर. Two equipotential surface, if they are to be intersecting each other, then at that particular point we are having the two directions of the electric potential, but it is not to be possible. That's why they are not to be intersecting each other. Next, the electric potential energy. It is to be the last topic of this chapter. The work done in moving a charge plus q from infinite to a point into the electric field against the electric force, this is to be called as the electric potential energy. It means माइनस इनफाइनाइट से लेकर आप किसी भी पॉइंट्स तक किसी एक चार्ज को लेके आए हैं, तो जो आपने वर्क डन कैलकुलेट किया है, दिस वर्क डन इज टू बी डिफाइंड इन टर्म्स ऑफ द इलेक्ट्रिक पोटेंशियल एनर्जी. Earlier we are discussing about the when the test charge is to be moving into towards that particular electric field region, then the force is to be variable, और उस force की value continuously क्या होगी, change होती जाएगी. It means the test charge is to be having a property of that particular electric potential energy, वो उतनी energy को conserve करता जाएगा. That's why it can able to just opposing that particular force, otherwise it is to be moved into the opposite directions. The electric potential energy is to be defined U. In terms of the U, it is to be equal to W equal to Q into V. And as per the formulation, due to the two charges, if you are having the two charges Q1 and Q2, they are to be placed into the electric field, then the electric potential energy is to be defined. It is to be 1 upon 4 pi epsilon naught Q1 Q2 upon R2 minus R1, or it is to be considered as U equal to K Q1 Q2 upon R12. The electric potential energy due to three charge system. Earlier we will discussed about the two charge system. Now we will consider about the three charge system. In case of the three charge system, it is to be important because the potential are to be different. Here just first we will consider about the electric potential energy upon the charge 1. It is to be defined in terms of the K Q1 Q2 upon R2 minus R1. Next, the potential energy upon the Q1 due to Q3, it is to be Q1 K Q1 Q3 upon R3 minus R1. Next, upon Q2 due to Q3, it is to be in terms of the K Q2 Q3 upon R3 minus R2, and the entire concluded result are to be in terms of the K Q1 Q2 upon R12, Q1 Q3 upon R31, Q2 Q3 अपॉन R32. ध्यान रखना यहाँ पे 1 2 है तो यहाँ भी 1 2 होगा, यहाँ 1 3 है तो यहाँ 3 1 होगा, ये 2 3 तो यहाँ पे 3 2 होगा. Be careful about it. For the n charge system, we are just to be having the generalized formulations. U equal to 1 by 2 1 upon 4 pi epsilon naught summation I equal to 1 to n summation j equal to 1 to n qi qj rj minus ri. It is to be the end of this chapter. But the important thing, why we are just to be considering the test charge always the positive charge. Test charge को हमेशा positive क्यों लेते हैं? We will already discussed in chapter first कि जब भी अपन फोर्सेस के प्रॉपर्टीज की बात करते हैं और नेचर ऑफ द फोर्सेस की बात करते हैं तो हमेशा अपन रिपल्सन ही को ही कंसिडर करते हैं. द सेम फिनोमिना इफ यू आर कंसिडरिंग द नेगेटिव चार्ज हियर, देन द पॉजिटिव चार्ज, the electric field due to that particular charge we will consider, then this charge is to be directly attracting this. It means yeah इसको attract करेगा, then there is no opposing force, there is no work done. It means the electrostatic potential की जो अपन ने phenomena discuss की है, it is not to be exist that particular case. That's why we are considering the test charge only as the positive charge. थैंक यू. ये वीडियो आपको कैसा लगा कमेंट करके ज़रूर बताएं. चैनल को सब्सक्राइब करें.